Okay, we are moving to the first 2 years. We're going to talk about the body and the mind. One thing you'll notice about this book is it kind of divides the stages up. And the first chapter will be about the biology, the body and the mind. The second chapter will be about the social aspect of things. So we've talked about in utero, we've talked about average weight and what is considered low weight versus normal weight. So the average weight for babies at birth is about 7 pounds, and that's actually because of a thing called stabilizing selection. Stabilizing selection means that the intermediate is chosen or selected for as opposed to either extreme. So 7 pounds, 8-pound babies are right in the middle, so that's a good weight. Anything below that, if you have a 2 or 3 pound baby, they're probably premature and they're going to have a lot of issues if they survive. And if you have on the other end of the spectrum, a 11 or 12 pound baby, they're also going to have challenges because they're so massive at birth, they'll have issues with respiratory and breathing and things like that. But just because your baby weighs 7 or 8 pounds doesn't mean that they're out of danger or anything like that. Things could always happen. So as we said in the last chapter, during your pregnancy, it's very important to take care of that baby. By the time they're 2 years old, they should be about 28 pounds. At birth, the average length is 20 inches, and at 2 years, 34 inches. Now again, these are norms. These are average measurements. Just because your baby isn't this weight or isn't this length doesn't mean that anything's wrong or unusual. This shows you how eat and sleep makes sense for babies. The increase in weight during the first years of life make it obvious to see why babies need to be fed at all hours of the night. Babies sleep usually in about 3-hour blocks, but they sleep a total of 15 to 17 hours a day, and the rest of the time they're eating. So if you look at this, shows percentiles. And percentiles mean that if your child's in the 90th percentile, they are larger than 90% of all other girls or boys. Boys are in the dotted lines, girls are in the straight lines. Make sure you pay attention to the left-hand side of the chart because that is weight in pounds, and that's what we deal with. The other side of the chart is kilograms. So it tells you from birth to 24 months about how much your baby should weigh. As I said, newborns sleep about 15 to 17 hours a day in 1 to 3 hour segments. It depends. Their sleep is primarily active sleep, so REM, rapid eye movement sleep. They have a high proportion of this, so if you look at a newborn sleeping, you can see their eyes going back and forth. They sleep and dream, and so it's active sleep. And again, because it's in segments, they get up and eat, or need to be fed, I should say. So in Opposing Perspectives in your book, it asks the question, where should babies sleep? Sleep patterns are starting to change, and U.S. middle-class infants usually sleep separated from their parents. European and North American mothers worry about privacy, but Asian, African, and Latin American infants actually co-sleep or bed share. Co-sleep means that they sleep in the same room as their parents, so their parents will have a bed, the baby will have a crib in the same room. Bed share means they actually sleep in the same bed with their parents. So the decision can be linked to culture. Certain cultures are a lot more acceptant of that. The age of the infant, the mother's education level. If they're in a depressed state, that can really matter. If they're in an initial state of depression, they might want the baby by them all of the time. But then as they get more and more depressed, kind of go to the opposite end of the spectrum and not want the baby around them at all. So if you know anybody that is doing this, please reach out. And the father involvement can also have something to do with it, because if you're a single parent, sometimes it's just easier to have your infant sleeping in the same room or even the same bed with you. So in the first 2 years, that brain growth is crucial for later cognition. Remember, we talked about cognitive theory with Piaget. And cognition isn't so much what they're thinking, it's how they're thinking. So that prenatal and postnatal brain growth during that first 2 years is crucial for how they think later on in life. Head sparing is a biological mechanism that actually protects the brain. Malnutrition can often disrupt body growth, and if you are malnourished for a brief period of time, we have a mechanism that will actually protect the brain, so your brain will not be damaged because of malnutrition. However, if the malnutrition continues for months, then your brain can be affected by malnutrition. The brain is the last part of the body to be damaged by malnutrition, and the brain pretty much is the last part of the body to be damaged by anything, because the brain will shut down all other parts of the body to save itself. So if you are in a coma, that is how they see if you are legally dead. If you are legally dead, you do not have any brain activity, and they test you twice, once and then 24 hours later. And if you do not have any brain activity, then you're legally dead. We have machines to basically run every part of our body except for our brain. So the basics, you have the prefrontal cortex, which is the area that specializes in planning, anticipation, and impulse control, and that's right at the very front of the brain. The cortex are the outer layers of the brain, and this is where thinking, feeling, and sensing occurs. Neurons are actually the cells of the nervous system. So we have billions of neurons in the central nervous system, some in the peripheral nervous system. And the axon is the fiber that extends from the neuron and basically transmits the electrical impulses down the neuron to other neurons or wherever they need to go. So dendrites extend from the neuron, and these are what receive the chemical impulses transmitted from other neurons by their axons. So if my head is the cell body, I would have extensions coming out like this, and those are the dendrites. So this is what's getting incoming signals. The incoming signals they would send to my cell body, which in my case would be my head. My cell body would determine what needs to be done, and then send that impulse down my axon, which would be my body in this particular case. Once it's sent down my axon, at the end of my axon is something called axon terminals. These have neurotransmitters. So whatever impulse is being sent, a neurotransmitter will be released and will cross the synapse, which is the intersection between two neurons, to get to the other dendrites so that the message can keep passing on. So if you imagine my dendrites here, an incoming message comes in, it goes to the cell body determines that it needs to be sent to another neuron, so it's carried down the axon, which would be my body. At the end of my axon, we have axon terminals, and then dendrites of another neuron are going to be right here. And that space in between is called the synapse. So the neurotransmitter, which is the chemical messenger, is going to leave this neuron and go across to this neuron. And then the signal will keep being sent on and on until it gets where it needs to go, of course. And there are hundreds of neurotransmitters that we have. So the neurotransmitters are the chemical messengers for the nervous system. So if you look at this photo, the cell bodies are those giant portions, and the axons and dendrites are all the smaller stringy things that you can see. Axons and dendrites can actually grow towards each other, but we're basically born with all of the neurons we're ever going to have. What we can do, though, is we can make new connections as we learn. But this tangled mess here is repeated over and over again in the human brain, so it kind of makes you wonder how the nervous system keeps things in order. But it does a great job of it. So throughout our life, those smaller dendrites will disappear, or they will grow. They will grow towards new neurons as the person continues to think and learn things. Specifics of the brain structure and growth depend, of course, on genes and maturation, but they also depend on experience. A lot of things we're going to talk about this semester depend on experience. That early dendrite growth is called transient exuberance because it's transient, meaning they can go away and grow to other areas and things like that. So unused dendrites wither, and it's called pruning. And what that does, it allows space between the neurons in the brain to allow more synapses and to allow new connections to be made so that we can think more complexly. So in order to get complex thinking, we have to go through pruning. We have to make space for it, basically. So new growth has to occur. Experience expectant things are things that are common, that all children should go through in order for normal development to occur. So things like love, touching, language, things like that are experience expectant. Experience dependent things are things that not every child has to go through, but it depends on their experiences. So culture, for example. If children are in different cultures, they may have different facial expressions or different sayings that they grow up with, different courtesies and different, I can't think of the word I'm looking for, different practices and rituals and things like that. So experience-dependent things are things that not every child has to go through, but it depends on their culture and things like that. This little boy is pretty excited about having an EEG of his brain activity. And this kind of research has actually found that babies respond to language a long time before they can actually speak it. So they can understand what's being said a long time before they can actually say things themselves. Experiences, again, are going to help connect neurons and help grow those dendrites. So we know a few things. We know that infants need stimulation. They need to play. They need to feel different sensations. They need to be encouraged to move. They also need protection. Shaken baby syndrome is a very life-threatening injury. And what happens is if the baby is shaken back and forth, his brain goes back and forth in the skull. And that's going to rupture blood vessels and break those neural connections. And it can very well be deadly. It can also cause brain damage if the baby survives. So we need to protect our children, protect our babies. Babies can't fight against themselves. They do have an inborn drive to remedy any damage and deficits, which is called self-righting, but they can only repair to an extent. Babies, when they're born, have two soft spots mainly, one on the top of their head and one on the back of their head. They have these soft spots because the skull hasn't completely formed yet. So with the skull not completely forming and not completely fused yet, it's a membrane that covers it. So if the baby's brain is being shook back and forth, it's not really set and protected yet. So shaken baby syndrome is a horrible thing. Okay, so how do we develop senses? Sensory development usually comes before intellectual or motor development. And there's a difference between sensation and perception. Sensation is the response of the sensory system when it detects a stimulus. So if you go outside and it's cold, you feel the cold. That's sensation. Perception is how every individual interprets that sensation. So you take in the sensory information, you process it, and then the brain interprets it. So if two people walk outside, one person says it's cold, the other person might say it's fine, it's not cold at all. And that's because of their perception. They can both sense the temperature, but their brains perceive it differently. And this often happens with color as well. So perception follows sensation. Receptors are crucial to this process. And you pick up the sensation, and then your brain interprets that sensation. So infants' brains are attuned to their own social experiences, so perception can occur. The auditory capacity to hear sounds is within the speech range, so they can hear us. Some people think that they can hear, fetuses can hear us in the womb. That's why they'll play music and talk to the babies and things like that. Parts of the cortex are actually dedicated to the senses, and they develop very rapidly. So hearing develops during the last trimester. This is the most advanced of the newborn senses. So 4 months after birth, they can understand speech. They can't necessarily talk, but they can understand speech. So hearing and language comprehension occur right in this area. There's 2 areas. One area is called Broca's area. That is what is responsible for being able to speak. So that's not fully formed yet in infants. But Wernicke's area is being able to comprehend or understand speech. That one is developing pretty rapidly, as you can tell. So hearing is one thing. You can hear, sounds are being made. Babies can usually recognize their name at about 6 months, so they know they're hearing something. They can hear loud sounds. They can be startled, but what they're hearing, perceiving, comes into play after some experience. Vision is the least mature sense at birth. Babies are actually legally blind when they're born. They focus between 4 and 30 inches away, and oftentimes if you put something too close, they start to go cross-eyed. Experience and maturation of the cortex continue to improve, though. So then they can visually scan their areas and start to pick up on details, recognize shape. And between 2 and 4 months, their binocular vision comes in. So they can actually use both of their eyes to focus, so that cross-eye doesn't really occur as much anymore. Depth perception is usually present by 3 months, but to understand depth requires experience. Like if you're looking at this pen, and I say, how far away is this pen? You guys know how far away this pen is because you've had experience dealing with depth and how far away things are. But a newborn isn't going to know how far away this is because they've never experienced it before. So they can see that it's not right in front of them, but they may be grasping at it for a while before they actually get it. Smell and taste function at birth and rapidly adapt. Foods of the cultures may aid in survival because bitter foods may actually protect them from poisons, because bitter poisons are usually bitter. And spicy foods may actually help with poisons. I wouldn't know, I don't eat spicy foods. But adaptation of taste and smell occur for both of these senses, and it's pretty rapid. If you've ever walked into a room and smelled cologne or something really strong, but then by the time you sat down, you didn't smell that anymore, that's because your sense of smell is adapted to it. If you've eaten something and it's really sour at first, but let's say you're eating a lemon candy and it's really sour at first, after a little bit, that sourness goes away because your taste has adapted to it. Touch is acute in infants. Newborns respond to being securely held, and pretty soon they actually prefer specific touches. Some touches may be experienced expectant for normal growth. Newborns need to be held, need to feel safe, need to feel loved in order to develop normally, in a nutshell. Pain and temperature are often connected to touch. Some people think that the fetus can feel pain. Others think that it doesn't mature until months or years later. So the question I would ask is, have you ever seen or heard, I should say, a baby being circumcised? Babies that are circumcised and babies that get their first shots cry. So is it a painful cry, or are they just crying because they're scared? That's the question. Reflexes are necessary for survival, and reflexes are things that you do not have to learn. Reflexes that maintain oxygen, like thrashing and the reflexive hiccups and sneezes and the breathing reflex. If a child says they're going to hold their breath until you give them their way, go ahead and let them hold their breath. Because at some point that breathing reflex is going to come into play and they're going to breathe. They're going to take a deep breath. Hiccups and sneezes, if you get something in your airway, we try to get it out. Crying, shivering, tucking the legs close to the body are reflexes that help maintain constant body temperature. If you cover an infant and it pushes the blankets away, it's probably hot. And then sucking and rooting and spitting up are reflexes that we automatically know that manage feeding and help us feed successfully. Other reflexes are indications of the state of the brain and body functions, but they're not necessary for survival. The Babinski reflex is normal in infants, but abnormal in adults. So if you have a baby's foot and you go like that and rub the bottom, they fan out their toes. That is a normal Babinski reflex. However, if you go like that to an adult's foot and go like this, they curl their toes in. If an adult does a Babinski reflex and when you go like this and rub the bottom of their foot, they fan their toes out, something is wrong neurologically. So it's normal for a baby to fan their toes out, normal for an adult to curl their toes in. The stepping reflex, as the name implies, if you put a baby by a surface, they will move their legs like they're stepping. If you let them go, they're going to fall. They're not going to walk. They're not a miracle baby. They're not fully advanced. It's just a reflex, just like the swimming reflex. If you throw a baby in the pool, they're going to swim. The palmar grasping reflex is if you put something in a baby's hand, they grab it. And the moral reflex is when a baby is laying down and then all of a sudden somebody bangs on the table. And they flail their arms out, their legs out, their eyes open really wide. And I think I would do that myself if somebody banged on the table next to me. But if the babies do all these things, it is completely normal. Gross motor skills are skills that require large movements. They develop from the head down and from the center out. So sitting unsupported, they can usually do first, about 6 months, 8 months. Then they can stand holding on to something, so they'll start pulling themselves up using a table or something. And then they can start crawling or creeping. Sometimes they'll rock back and forth and then eventually start crawling. Then they can stand without holding on to anything. And then they can master walking really well. A few months later, they can walk backwards. A few months later, they can start to run. And it's really not until about 26 months that they can actually jump. Fine motor skills are those that are smaller movements. So your hands, very importantly. They can be shaped by culture and opportunity. So some cultures have certain beliefs. Some others don't have opportunities to have rattles and a lot of toys and things like that. So the hands and fingers, like picking up coins and drawing, these are fine motor skills. So the first thing they can do is grasp the rattle, and then they can start reaching to hold an object, and then they can do the thumb and finger grasping, and then they can stack some blocks, and the last thing they can do is imitate a vertical line. So we have 3 interacting elements that underlie these motor skills: muscle strength, brain maturation, and practice. Muscle strength, of course, they have to have some sort of muscle tone and muscle strength to pick things up, pick themselves up, to do things. The brain has to be mature enough so that we have the neuronal connections to get the messengers where they need to go for these muscles to act. And practice, of course. Babies who start crawling usually start rocking back and forth before they crawl. When they start walking, they fall down a lot. Practice makes perfect. When they start running, they'll fall down a lot. Playing the piano is something that takes a lot of practice. So the whole point of these sensations and motor skills is for social interaction, comfort, and learning. So we want our children to interact with other children. We also want them to feel comfortable, and we want them to be able to learn new things. The United Nations estimates that more than 8 billion children were born between 1950 and 2015, and almost 1 billion of those children died before the age of 5. However, almost all newborns who survived the first month live to adulthood now. So we're getting better at treatment. Our medications are getting better. Our vaccinations are getting better. Our surgery techniques are getting better. We're learning more about certain disorders, and we can now fix a lot of things that we couldn't fix before. Infant survival and maternal education are the two main reasons that the fertility rate in 2010 was half of the 1950 rate. So now we're also having more children survive, so we're not having as many children, and mothers are also getting educated on how to better take care of their babies, and they're also starting to get educations and go into the job force. SIDS is sudden infant death syndrome. Until the mid-1990s, tens of thousands of SIDS deaths were in North America and England. Most deaths were related to sleeping position. So there's a program called the Back to Sleep program that cut the SIDS rate dramatically. Other risks: low birth weight, exposure to cigarette smoke, if there's soft blankets or pillows that they can get caught up in, bed sharing, so if you're sleeping in the same bed and accidentally roll over on them, and also abnormalities in the brainstem, heart, mitochondria, or microbiome, so their immediate surroundings, or mitochondria, which generate the ATP, or the heart, of course, which pumps the blood, or the brainstem, which is where our breathing centers are located. Immunizations have also helped. It basically gets the immune system ready to resist certain diseases. This contributes to reduced mortality and population growth. Smallpox, polio, and measles have basically been eradicated because of immunizations. So these used to be epidemics, and now they're basically gone. However, immunizations are not safe for everyone. If you have a compromised immune system, like if you have HIV or something like that, newborns and embryos that have experienced rubella immunizations may not be safe for them. Problems, side reactions, and side effects. Also, parental refusal because of the myths. Some people actually die from getting immunizations, but the numbers are very low. And not to minimize anyone's death, but a lot of parents go off of, well, this one person died, I don't want my children to die. So, unfortunately, a lot of people do not get their children immunized, and that helps the spread of diseases. So, these problems can really get blown out of proportion. If somebody has a side effect, again, they have to tell you all the side effects. That doesn't mean that they're usual. That doesn't mean you're going to have these side effects. It just means they're possible. If we listen to the side effects of every medication out there, nobody would ever take medication. Adequate nutrition, of course, is important as well. Breastfeeding is the best food for the baby. It reduces malnutrition. It reduces risks. Without breastfeeding, your body and brain can be stunted. The growth can be stunted. Malnutrition increases risks of these diseases, including sudden infant death syndrome. Breastfed babies are less likely to be obese, develop heart disease, asthma, or allergies. And as the infant gets older, the breast milk composition actually adjusts to the baby's changing nutritional needs. So breast milk is the most natural food for the baby, and it actually changes as the baby gets older so that the baby is properly getting proper nutrition. We have a few different types. Protein calorie malnutrition is simply if you're not getting enough calories. Stunting is if you're small for your age kind of thing. And wasting, as the name implies, you're kind of wasting away. You're not getting proper nutrition at all. So these three things we do not see often in our country, but in other countries you see them a lot more often. Sorry. So if you have malnutrition, that's a chronic problem, meaning that it happens all of the time. Brains may not develop normally. Your immunity may be reduced, and some diseases result directly from malnutrition. In marasmus, the tissues start to waste away during the first year, and unfortunately the child passes away. In kwashiorkor, it happens after age 1, and what happens is the hair starts to thin and their abdominal area swells from excess fluid, and that's not obviously a good thing either. Okay, we talked about Piaget before, assimilation and accommodation. Assimilation is when new experiences are interpreted to fit into your old ideas. And accommodation is when your old ideas are restructured to accommodate new experiences. So you can assimilate or you can accommodate. So if you fit your new experiences into your old ideas, if you mold them, so to speak, or interpret them with relation to your old ideas, you're assimilating. But if you're actually restructuring what you used to think in your old ideas to accommodate and include these new experiences, then you're accommodating. So sensory motor intelligence is Piaget's first stage. They use their senses and their motor skills. This is the 6 stages of sensory motor intelligence, and make sure you know these for your test. Reflexes are just involuntary, they happen. First acquired adaptations, so accommodation and coordination of these reflexes. Then they start making interesting sights last. Then they have new adaptations and anticipation, so they actually become more deliberate. They act with a purpose. Then they discover new things through active experimentations, like if they keep flushing the teddy bear down the toilet kind of thing. And then they start to think before they're doing things. They have new ways of achieving a goal, and they don't have to use trial and error. So active experimentations are kind of like trial and error. And finally, they end up thinking about how they could do this without trying it first and making a mistake. Once we evaluate Piaget, though, we found that he had an underestimation of the age that the different accomplishments occurred. So he kind of underestimated our children. It did inspire future research, though. The sensory and motor ability emphasis kind of limited the early understanding, though, of child cognition. So even though it inspired future research, it kind of held us back as well. Information processing theory is modeled on computer functioning. It basically involves step-by-step description of how you think, the mechanisms of thought. It does add insight to understanding of cognition, but this has actually overturned some of Piaget's conclusions, including the concept of object permanence, which is that we realize objects are actually there. They're not going to go away. Like when your mom plays peekaboo, she's not totally disappearing kind of thing. So according to classic developmental theory, infants store no memories in their first year. They have what's called infantile amnesia. And I don't think many of us can remember being 6 months old. Developmentalists now agree, though, that memory improves monthly and that very young infants can remember certain things. Rove Collier's mobile kicking research shows that brains are active organs, even in infants, and that infants can remember general goals and patterns and objects and specific events. And Everyone's going to be different. The universal sequence of language is listening and responding, where we have child-directed speech, which is that speech that we all get when we see a baby. Oh my gosh, you are so cute! We get high-pitched, we speak in really simple words, simple terms, and we repeat ourselves often. So after they listen and respond, they go to babbling, which are they repeat certain syllables like ba 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 ba. And this usually begins between 6 and 9 months old. Then they do a gradual imitation of accents, consonants, and gestures. So they may start talking with your hands, or they imitate what they hear. So about a year, babies speak their first words, and then they learn about 1 or 2 new words a week. A hollow phrase is a single word used to express a whole meaningful thought. So infants differ in their use of various parts of speech depending on what language they're using. Every language is different. Some languages use more nouns, some use more verbs. Just depends on the language they're using. Once vocabulary reaches about 50 expressed words, it builds rapidly at a rate of 50 to 100 words a month. So it's called the naming explosion. 21 months olds say twice as many words as 18-month-olds. And again, the ratio of nouns to verbs varies from place to place. Finally, they can put words together. Proficiency in grammar actually correlates with sentence length. So grammar is everything that we use to communicate meaning. So the sequence, the prefixes, suffixes, the intonation we use, how loud we are, verbs, pronouns, prepositions, all of that. And the longer the sentences that they can form, the more proficient they are in grammar, and vice versa. So we have a few theories here. Infants need to be taught is one. E.F. Skinner noticed that spontaneous babbling is usually reinforced. So when a baby's like, ba, 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 we're all excited and we're like, yes, ba, 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 ba. So parents are expert teachers, and other caregivers help them teach children to speak. So if you have a frequent repetition of words, it's instructive, and if those words are linked to pleasures in daily life, it's reinforced. So well-taught infants become well-spoken children. Theory 2 is social interaction fosters infant language. So infants communicate because humans have evolved as social beings. So every culture has practices that further social interaction, including talking. So we do not necessarily teach infants, we kind of lead infants to learn language. So because we're interacting with them and because we're interacting with each other, they learn to speak. So instead of directly teaching them to speak, they're learning because they're seeing it. They're interacting with us. Infants teach themselves. Language learning is innate. So again, we don't teach it. It's not a product of social interaction. It's taught themselves. So Chomsky said that language is too complex to be mastered through step-by-step conditioning. So Chomsky said that language is innate, and we all have the ability, we all have this language acquisition device that allows us to speak. So we teach ourselves to speak. So which perspective is correct? All of them offer some insight into language acquisition, and basically everything contributes to early language. Different elements of the language apparatus may have evolved in different ways, but it's really being taught, it's really having these innate components, and it's really social interaction that all kind of contribute to language learning. So currently we say that we're not behaviorists, we're not social learners, and we're not innately driven. We're all three. So some we see by interacting and learn it. Some we kind of know, we're born with it, and other behaviors we can observe and then do. Evolutionary theorists say that language is a crucial trait, and that's what makes humans unique, because no other species on this earth can speak language. So they say that's what makes us unique. They have taught gorillas and chimpanzees to communicate, but it's not official language. So language makes humans human in a nutshell. And we learn language using everything at our disposal. So we have some biological components, there are some behavioral components, and there are some social components. So that is all for now. So we will talk about chapter 4 next time.